Welcome back, Algebra 2. In this video lesson, we're going to be looking at the domain and range of the 6 trig functions based on our understanding of the unit circle. So if you remember in the previous lesson, we talked about the unit circle, which is just a circle of radius 1. And then we talked about angles and standard position. And in particular, our focus was on the terminal side of this angle and where it intersects the unit circle. That point we'll call x comma y, and we define the 6 trig functions in terms of that point. We define sine theta to be the y coordinate. We define cosine of theta to be the x coordinate. We define tangent of theta just to be y coordinate over x coordinate, which in this case x can equal 0. We define cosecant of theta to be 1 over y, where y can equal 0. We define secant to be 1 over x. And we define cotangent to be x over y. And so what you should notice here is that if I were to give you a random angle, you can always find the point on the unit circle that corresponds to that angle, right? And so if you think about it, cosine of any angle then will always exist because, again, you'll find a point on the unit circle that corresponds to that angle, and sine of any angle will exist. And so using that reasoning then, the domain of the sine and cosine function should be all real numbers. Or using interval notation, you can say this is negative infinity to infinity, right? All real numbers. And so in this case, you can find sine and cosine of any number that you want. Now let's look at our next functions. So we'll be looking at the tangent function now. But before we do that, I want to draw a unit circle. And for this particular unit circle, I'm just going to label the 4 points that are on the x or the y axis. And so if you think about what tangent of theta is, you can think of it as sine theta over cosine theta using our quotient identity. You can also think of this as x over y, right? Where x and y are the points on the unit circle. And so when I want to find the domain of the tangent function, because I know that tangent of theta will be defined at a lot of values, it'll be much easier to describe the domain in terms of the values for which it's undefined. So really what I'm going to ask myself is, knowing that x cannot equal 0, I want to figure out when does x equal 0? Which is the same thing as asking, when does cosine of theta equal 0? And so what I want to do is figure out what angles correspond to these 2 points. And the reason why I chose those 2 points on the unit circle is because those are the only 2 points on the unit circle for which the x coordinate is 0. And we know cosine of theta corresponds to the x coordinate. Those angles would be pi over 2 radians, or 90 degrees, 3 pi over 2 radians, 5 pi over 2 radians, 7 pi over 2 radians, dot, dot, dot. I want you to picture these angles, and the terminal side will always lie on the y-axis. You can also look at negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and this would also continue in this manner. So what you notice then is that for the tangent function, the domain is everything except what makes the bottom 0. The angles that make the bottom 0 would be odd multiples of pi over 2. And so the domain of the tangent function will just be all real numbers except odd multiples of pi over 2. Now, the nice thing about this is that if I know the domain of the tangent function, I also know the domain of another trig function where the denominator will be x. That would be the secant function, right? Because secant of theta is just a reciprocal of cosine. So I know this is just 1 over x. And so based on that, I know that the secant function will have the same domain as the tangent function. So we're going to apply the same kind of approach when we're looking at the domain of cotangent and cosecant. So once again, I want to draw another unit circle. And I want to label these 4 points here. These are the 4 points that correspond to quadrantal angles. And so looking at the cotangent function, which if you remember, you can think of it as cosine of theta over sine of theta, or you can think of it as x over y when you're looking at the point on the unit circle. We're going to ask ourselves the exact same question, right? When does the denominator equal 0? That's the same thing as asking for what angles would sine of theta equal 0. And so because we know sine of theta corresponds to the y-coordinate of a point on the unit circle, what we're going to do is we're going to look at these 2 points here because, again, their y-coordinates are 0. And then we want to figure out what are all the angles that correspond to those 2 points. So I know 0 radians would be one of them, or 0 degrees. I know pi radians, or 180 degrees, would be another one. I know 2 pi, which is 1 revolution, would correspond to one of those points. So with 3 pi, 4 pi, dot, dot, dot. And similarly, you can go negative pi, negative 2 pi, negative 3 pi, dot, dot, dot. And so in the end, we can simply classify these values as integer multiples of pi. In other words, just pi times an integer. So the domain of the cotangent function will be all real numbers except integer multiples of pi. And the nice thing is, because I know the domain of cotangent of theta, I can use that to find the domain of cosecant of theta, because cosecant of theta, if you remember, is a reciprocal of sine of theta, which is just 1 over y. So I know that they're going to have the same domains. So again, when you're looking at the domain of these trig functions, understand that sine and cosine, the domain is all real numbers because you can always find a point on the unit circle that corresponds to that angle. And so cosine of theta and sine of theta will always exist. But for tangent, cotangent, secant, cosecant, you have to be careful because you can write each of those trig functions as a ratio, right? And whenever you have a ratio, you have to make sure that the denominator is never 0, okay? Now we're going to be looking at the range of our trig functions. When we think of range, we think of the set of all outputs. So let's draw another unit circle. Let's define these 4 points that correspond to the quadrantal angles. And let's just draw a random angle in standard position. We'll call this theta. And this point right here that corresponds to theta, we know that the x-coordinate is cosine of theta, and we know the y-coordinate is sine of theta. So for any given angle theta, what can you tell me about cosine of theta? So if you look at any point on this unit circle, and we're looking at cosine of theta, we're just looking at the x-coordinates. And my hope is you notice that these x-coordinates will always be between -1 and 1 inclusive. Right? The smallest x-coordinate I can ever get is -1. And the largest x-coordinate I can ever get for a point on the unit circle is +1. And you'll get everything in between. So that tells me that the range of the cosine function is between -1 and 1. Using interval notation. By the same kind of reasoning, if we look at the sine function, I know that sine will be the y-coordinates of the point. And if you notice, the lowest y-coordinate that it can take on is -1. And the greatest y-coordinate it can take on is +1. So that tells me that sine theta will take on values between -1 and 1. And so sine and cosine have the same domain and the same range, right? Now let's look at cosecant and secant. So for cosecant of theta, we know that cosecant of theta is 1 over sine theta. To better understand the range of the cosecant function, what we're going to do is look at a function that we've graphed before, which is f of x equals 1 over x. If you remember, the graph will look something like this. And so what we notice for the cosecant function is that the cosecant function is 1 over sine. And so the cosecant function depends on what the sine values take on, right? And so because we know that the sine function only takes on values between -1 and 1, what I can do is I can look at this function here and look at the range of that function when x is between -1 and 1. Now obviously here x can equal 0. So what we're going to do is we're going to just focus on the portion of the graph when x is between -1 and 1, because the range of that function f of x equals 1 over x would be the same as the range of cosecant of theta, which is 1 over sine theta. And so the range of the cosecant function, if you look at this graph here, would be everything that's less than or equal to -1, which would be this portion right here, or everything greater than or equal to 1. And using interval notation, it looks something like that. You could use the same kind of reasoning to get that the secant function, which is 1 over cosine, will have the same range. Lastly, we have tangent and cotangent. And for now, we're just going to accept as fact that the range is all real numbers. In later sections, when we start graphing these functions, you'll see exactly how the range is all real numbers. But for now, let's just accept it as fact. So guys, understand the domain and range of these trig functions. Understand how we came up with the domain and range of these trig functions based on the fact that we know the unit circle and how the points on the unit circle correspond to the 6 trig functions.